Hello, everyone.
Yes, sir.
Yes, sir.
Oh, okay. Whiteboard. Can you see this? I have shared.
Yes, sir.
Okay, thank you. So in the previous lecture, I think we have discussed all the properties of Z transform and Laplace transform, and we have not done some question or some practice problem, isn't it? Now, today we will see some questions related to the property that we have discussed earlier, because everything, I think the topic, most of the topic has been already covered. So write a question. Find the response of the continuous time LTI system have impulse response is equal to h of t is equal to e to the power 8 t ut, and the input ft is equal to e to the power 5t ut. Is it visible to everyone? I am writing something. Can you see?
Yes, sir.
Okay. So this is impulse response of LTI system, and this type of input is given to the system. The question is, find the response of the system. Impulse response means when delta function is given to the system, then the output is the impulse response. So according to this relationship, according to this block diagram, see what happen if impulse response and this impulse input, this is input and this is output. Take Laplace transform. In input side, you will see the Laplace transform of delta function is equal to 1, and in output side, Laplace transform of, suppose, ht is equal to h of s. Now take the ratio of input, basically Laplace transform of input divided by Laplace transform of output. What is the Laplace transform of input? Laplace transform of input is Laplace transform of delta function. Sorry, I have written wrong. Up to this, okay. See, after this, input side of Laplace transform is input is delta function. Laplace transform to delta function is 1, and in output side, Laplace transform of output is Laplace transform of ht, that is h of s. Now do one thing here. Take the ratio of Laplace transform of output to the Laplace transform of input. What happened? Laplace transform of output is Laplace transform, basically we are saying that ht, and Laplace transform of input means we are saying that Laplace transform of delta function. So this is equal to h of s divided by 1. Now from this discussion we can relate the input and output. Laplace transform of any type of input, any input, divided by Laplace transform of, sorry again, Laplace transform of output to the Laplace transform of any input is equal to h of s. Now this relationship will become a universal relationship, and very important, keep always in mind. Universal means this will apply for any input, any. For this question, input is, e to the power 5t ut. Here h of s is the Laplace transform of h of t, and h of t is given, means Laplace transform of e to the power 8t ut, and Laplace transform of 8t ut is 1 by s minus 8, and ROC is sigma greater than 8. Correct? Because this is right-sided signal, kind of causal signal. So the sigma greater than the location of pole, this is the ROC. So h of s is equal to 1 by s minus a. Now here, what is the Laplace transform of this input? Laplace transform of input is equal to 1 by s minus 5, and ROC is sigma greater than 5. Now from the universal relationship that already we have derived, what will be the Laplace transform of output? Laplace transform of output is equal to h of s multiplied with Laplace transform of input, and this is 1 by s minus 8 and 1 by s minus 5. So the Laplace transform of output is equal to 1 by s minus 8 into s minus 5, and the common ROC of sigma greater than 8 and sigma greater than 5 is equal to plot the ROC diagram, this real x which is sigma, and somewhere there here 8, somewhere there 5 and 8, like this. Sigma greater than, this is sigma greater than 5, and sigma greater than 8 will be from here. So the common region will be from sigma is equal to 8 to infinity. This is 8. The common region is from 8. So the common ROC is sigma greater than 8. Means this Laplace transform will perform good or the converge in this region only. Now what will be the output? Take both the side, inverse Laplace transform. So the output will become inverse Laplace transform of 1 by s minus 8 into s minus 5 in the region of sigma greater than 8, and this is your duty to do the inverse Laplace and to get the output. That will become the final response of the LTI system. So this is one kind of question that has been asked many times in many places, in university exam or in other competitive exam and so on. Do the practice of the question like this. Another application of Laplace transform is that solution of differential equation. Here this is the basically the term, the statement is like mathematics. Is already you have studied this type of topic in mathematics, but if you see the statement in terms of signal and system, the differential equation is basically the relationship. Differential equation represents a relationship. What relationship? Between input and output. So here also we will study the differential equation solution in signal system, because the relationship between input and output anywhere, that is basically the subject to our concept. See this here, y double dash t, 5 double single dash t, 6 yt is equal to xt. This xt is one kind of signal, and yt differential value of y, algebraic sum and so on, this type of y is another signal. Here we can see that two signals present, means one of the signal is input and other signal is output. This in general, the single variable, single term is considered as input. This is in general, or the relationship will become like this only, and another signal will become the output. and the relationship, this represents any LTI system. So this is not a mathematics, this is single system. This is one way of representing the system. Another way of representing system that already we have discussed in the previous question, here h of t. H of t also represents the relationship between input and output, like this block diagram that you have seen. Okay. So this different type of representation of the system. To do this, to solve this question, first you have to perform Laplace transform on both the sides. Here some condition is also given. Y of 0 is equal to 2, y dash 0 is 1, xt is equal to e to the power minus t ut. This is the value of y and derivative of y at t is equal to 0. At t is equal to 0. These are the initial conditions. They are called initial condition. These initial condition will be used after 1 or 2, 3 steps. First step is to take the Laplace transform of y double dash. Now suppose y t have a Laplace transform is y of s. Let's say y t have Laplace transform y s. You have to apply here derivative property. Y dash t. What will be the Laplace transform of y dash t? Laplace transform of y dash t means derivative of y t is s ys minus y0, and y double dash t, second derivative of yt, Laplace transform of this is equal to s square ys minus s y0 minus y dash 0. So here you can see the y0 and y dash 0 is given in this expression. That's why the initial condition is given in this question. Now every steps is clear. According to this, perform Laplace transform and solve the differential equation. After solving the differential equation, you will get a relationship like in term of h of s only, means y of s divided by x of s, and that is the ratio of Laplace transform of output to the Laplace transform of input, and that is the transfer function. And now next step, what to do? You are going very easily. Suppose this type of expression is used in this given question. Question is y double dash, sorry, लिखते हैं. Okay. Apply the Laplace transform in this expression. S square y of s minus s y0 minus y dash 0 plus 5 into y dash t, Laplace transform of y dash t is equal to s ys minus y0 plus 6 into y of s is equal to x of s. Now separate and take the common of this s square y of s minus s y of 0 is equal to 2 here 5 times y of 0, sorry this term, this is 2s, basically we can write like this, and this is y dash 0 is 1 plus 5 s ys minus 10 into y0 is 2, 10 plus 6 ys is equal to x of s. Here s square ys 2s 5s ys take ys as common so that we can represent the expression in term of ys divided by xs. If you take the common this term, you will get s square plus 5s plus 6 and this term, this term, this term, and the rest s, sorry, 2s I think I have done some mistake. Can you find the mistake? Anyone? Are you listening? No, no one is listening. Please do respond. So s square y of s minus s y0 minus y dash 0 plus 5 times rest everything ys minus s, sorry, s here minus y of 0 plus 6ys is equal to xs. Take the common and try to find the ratio of this. Do this. If you find this represents the transfer function. Here basically I have not given the input. Basically this is only the differential solution of differential equation. In this expression here xt is directly written as e to the power minus 60 ut. So this xt is replaced by this term. So you have only yt. So the relationship, the differential equation, the solution of this question will become in term of y of s only. And after taking the inverse Laplace transform, you will see the solution y of t. Basically, I missed some other input. That's why this is the problem. So only try to solve this question according to the given information only. What is this? Yes. This x of s is equal to 1 by s plus 1, because x of t is equal to e to the power minus t ut. That's why this is equal to 1 by s plus 1. Now see y of s, take common s square. Here this term will become, first write this one, minus 2s minus 1 plus 5s ys minus 5s ys minus is 10 plus 6 ys s square plus 5s plus 6 is equal to 1 by s plus 1, and rest everything, this term and this term will come this side, plus 2s plus 11. Now y of s is equal to 1 plus 2s plus 11 into s
सर
plus 1.
2s नहीं होगा सर.
Yes,
सर 2s नहीं होगा सर, वो 2 into 5 होगा.
2 into 5 where? ये 2s है ना, ये
So y
y
of
of
0.
y of 0 is equal to 2 given है,
Yes sir, okay sir.
ठीक है ना. हाँ, this is good, divided by s plus 1. And now this term will come this side as s square plus 5s plus 6. So this will become this is the whole expression. Basically you can say 1 plus 2s plus 11 into s plus 1 divided by s plus 1. Here also there will be one term s plus 1 and s plus 2 into s plus 3. This is the all about. Y of s will become this type of expression in term of, and finally take inverse Laplace, it will become y of t. So this is simple according to your given information, but this is not the question related to the signal system because I missed some information according to this question. So no problem, do this differential equation solution. Some another types of question, and also you should do practice. Suppose a function given t, this is f of t, to 5 7, this is 6, here origin. f of t is given as this graph. find the Laplace transform of f of t. To solve this question, first you have to write, basically the function f of 2 is given in term of graph, so Laplace transform cannot perform on the graph. You have to write f of t in term of expression. Earlier I have discussed the representation of any graphical function or representation of any function in term of u of t and r of t, ramp function, impulse function, and using or any kind of basic function, that sinusoidal or any exponential function, etc. So try to use that elementary function to represent this type of graph. How to do? Simply you can see at t equal to 2 there is a change in state, and again at t equal to 5 there is a change in slope. Again there is some change in slope at t equal to 7. So you can see that sometimes state is changing, sometimes slope is changing. So this expression can be written in terms of step function and ramp function. F of t is equal to 6 amplitude, 6 height is changing, है ना, at location t is equal to 2. So it can be written as 6 u of t minus 2. Now at t equal to 2, the operation complete. Again, this height maintains at t is equal to 5 seconds. Sorry. And the slope changes at t is equal to 5. Slope of this line is 0. And what is the slope of this inclined line? Slope of this line can be calculated as change in y divided by change in x. What is the change in y? Is height of y is 6 and change in x-axis is 2, 5 to 7. Difference is 2. Basically this is 3. But here you can see the slope is negative. From here vertical axis, after vertical axis, here to here slope is positive. Slope is positive. Any line between this, any line between this, up to here positive. After this here slope is negative. Any line in second quadrant inclined like this only, you can say all these lines have positive slope. All these lines have negative slope. Simple, hai? Yeah, you can say directly that change in y is positive and change in x is negative. You should write here. Directly it will become negative. So the slope of this line is -3 and slope of this line is 0. Slope of parallel axis. Slope of this parallel to x axis is 0. Correct? So the change in slope at t is equal to 5 is -3. Sorry. That's why here write -3 r of t minus 5. This 5 represents the location and this amplitude of r, coefficient of r represents the change in slope. Now again slope changes. From where to where? This -3 to slope of this axis is 0. Slope of the line from 7 second. 7 second के बाद इस एक्सिस का स्लोप 0 है. And the slope of the line previous to this second, before the 7 second, this inclined line is 3. So the change final slope is 0 and initial earlier to 7 slope is -3. Slope at 7. Slope at 7 is equal to final slope minus earlier slope. This is equal to 3. Means you have to write an extra term of slope having coefficient +3 and the time shift is 7. Very simple expression. F of t is equal to 6 ut minus 2 minus 3 rt minus 5 plus 3 rt minus 7. This simple expression, now you can easily perform Laplace transform of f of t, and you know some property that u of t Laplace transform is 1 by s if time shift is given t minus t naught, then what to do? E to the power minus s t naught divided by s. Apply this property. Again, r of t Laplace transform is 1 by s square, and shift t minus t naught is given s minus t naught divided by s square. So apply these two properties and you can easily find the Laplace transform. This will become 6 e to the power minus 2 s divided by s minus 3 by s square into e to the power minus 5s plus this is the do one practice example. T is like this, x-axis, y-axis, graph is given between x-axis and y-axis, f of t at 4. After 4 it is exponential decaying. It is e to the power minus t. Graph of this e to the power minus 3 given from t equal to 4 seconds. What will be the amplitude? Slope is not given. Still you can calculate the amplitude by putting the value of t in this expression, because the value of this graph at t equal to 4 seconds will be e to the power minus 3 into 4, that is equal to e to the power minus 12. This is the amplitude of the slope, maximum amplitude of this given graph. Find the Laplace transform of f of t. See how to represent this signal in terms of known function. F of t is equal to, this is straight line drawn from 0 to equal to 4 seconds.
So we have to join another lectures.
Okay, okay, no problem. Do this question as a homework. Very easy question है, solve करो. ठीक है. Thank you. We will meet again in the next lecture.